Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. This video is dedicated to the derivation of centripetal and tangential acceleration of a particle that executes circular path. Let us dive into the math behind circular motion. Consider a particle that moves in a circular path, say in anti-clockwise direction for example, of radius r. I shall take the center of the circle to be origin and x and y axis. Then any arbitrary position of the particle, say at an angle theta with x-axis. So at that position, the coordinates of the particle are r cos theta, r sin theta. So in order to derive the linear acceleration of the particle, we will have to differentiate velocity vector. And to get velocity vector, we will have to differentiate the position vector. And to know the position vector, so I have to take the coordinate axis and get the coordinates of the point so that I can define the position vector of the particle. So this is the order that we are going to follow now. But before we do that differentiation part, let me define two important vectors in two important directions. Number one, a unit vector in the normal direction, I'll name it as n cap, which is directed away from the center in the radial or normal direction. Another one is t cap along the direction of the tangent or the tangential direction. So n cap and t cap are unit vectors along the normal and tangent respectively. Now the position vector of the particle is r cos theta I cap plus r sin theta j cap. This is the basic concept of vectors. The position vector of any point x comma y in a plane is given by x I cap plus y j cap. And I can also write n cap and t cap in terms of theta, because as theta changes, the direction of n cap and t cap is also changing. So t cap is making an angle theta with the vertical, so resolving, so it is a unit vector of magnitude 1. So resolving t cap, the x component is 1 sin theta, y is 1 cos theta. Similarly, the n cap is making an angle theta with the horizontal. So resolving the vector, we get cos theta along x-axis and sin theta along y-axis. I can write t cap as minus sin theta I cap plus cos theta j cap, and n cap as cos theta I cap plus sin theta j cap. Now the tools are ready. We have to differentiate position vector to get velocity. So let us do that. So velocity v bar is nothing but dr bar by dt. That is derivative of this position vector r cos theta I cap plus r sin theta j cap. R is constant, it is the radius of the circular path. Theta is variable. As the particle moves in the circular path, theta keeps changing. And d theta by dt, the rate at which the angular displacement changes, is angular velocity. And also consider some angular acceleration, which is d omega by dt. Suppose if omega is changing with time, the rate at which omega changes with time is angular acceleration. So I am taking the most generic case of a non-uniform circular motion. There is some angular acceleration. So d theta by dt is omega, d omega by dt is alpha. I am going to use the same. So when you differentiate this cos theta function with respect to time, I have to apply the chain rule of differentiation. Derivative of cos theta is minus sin theta, but that is with respect to theta. In this case, I have to differentiate with respect to time. So it is derivative of cos theta with respect to theta into derivative of theta with respect to time. That gives r into derivative of cos theta is minus sin theta into derivative of theta d theta by dt I cap plus r into derivative of sin theta is cos theta into d theta by dt j cap. D theta by dt is omega. So r omega is common in both terms. I can write minus r omega sin theta I cap plus r omega cos theta j cap. Solving this, taking r omega common. So v bar is r omega into minus sin theta I cap plus cos theta j cap. This is the velocity vector as a function of theta. And if you observe this minus sin theta I cap plus cos theta j cap, it is nothing but t cap, the unit vector along the tangent. So velocity vector can be written as v bar is equal to r omega t cap, which says that the magnitude of velocity is r omega and it is directed along the tangent. It is a very obvious thing. Any particle will have its velocity directed along the tangent of its path. So even if it is a circular path, the direction of velocity is along the tangent. And the mathematics is also saying the same. It is confirming the same. V bar is r omega t cap. It is a vector of magnitude r omega which is directed along t cap. So the magnitude of velocity or the linear speed is equal to r omega directed along the tangent. This is a pretty famous equation. Anybody who is into physics knows this. V is equal to r omega is the equation relating linear speed and angular velocity of a particle executing circular path. Now let us differentiate velocity vector. So a bar is dv bar by dt. Now dv bar is a function of both omega and theta. We are assuming that omega is also changing. So omega changes and the other function minus sine theta I cap plus cos theta j cap, this also changes. So v bar is like the product of two functions or two variables. So when you have to differentiate something which is in the form of uv, you have to apply uv rule of differentiation, which is u into v dash plus v into u dash. Basics of differentiation again. So r I'll take common because it is constant. R that is common. Omega I'll take it as u minus sine theta I cap plus cos theta j cap. I'll consider it as v. So r into omega of derivative of minus sine theta, that is minus cos theta into d theta by dt I cap plus derivative of cos theta, that is minus sine theta into d theta by dt j cap. So u into v dash is done plus v into u dash. V is minus sine theta I cap plus cos theta j cap into u dash, that is d omega by dt. Now simplifying this, where I write d theta by dt as omega and d omega by dt as alpha. So the first term omega square or minus omega square into cos theta I cap plus sine theta j cap, plus the second term is alpha into minus sine theta I cap plus cos theta j cap. Now there is this t cap and n cap in this equation. I can write a bar as minus r omega square cos theta I cap plus sine theta j cap is nothing but n cap, r omega square minus n cap, and r alpha t cap. This equation says that the linear acceleration has got two components, that two perpendicular components. One component is directed along minus n cap. I have taken n cap or defined n cap away from the center. Minus n cap is a direction which is directed towards the center. So one component of acceleration is directed towards the center, the other component is along the tangent. So the component which is directed towards the center is called as centripetal component of acceleration or centripetal acceleration. And the component of acceleration which is along the tangent is tangential acceleration. So the words centripetal and tangential are only implying the direction of the components of the acceleration, but nothing else. So if a particle has to trace circular path, definitely there is an acceleration in the centripetal direction. As you can see, minus n cap is the centripetal direction. So that centripetal acceleration has got a magnitude of r omega square, and omega can be written as v by r. Solving that, we get v square by r. So the expression for centripetal acceleration is omega square r or v square by r. Then tangential acceleration is r alpha. So for a particle which moves in the circular path, the linear acceleration can be split into two components, AC bar plus AT bar. The centripetal component is responsible for change of the direction of velocity, whereas the tangential component of acceleration is responsible for change in magnitude of the velocity. So the magnitude of acceleration is root over AC square plus AT square because AC and AT are perpendicular. So numerically it is root over omega square r whole square plus r alpha whole square. So very important thing to be understood here is that the word centripetal is only a substitute for the phrase something which is directed toward the center. When you analyze the dynamics of circular motion, there should be some net force which is directed toward the center that gives this necessary centripetal acceleration. Otherwise, the particle cannot be in circular motion. That net force which is directed towards the center, which provides the necessary centripetal acceleration, is called as centripetal force. Centripetal force is not a special type of force. It is only a net force in the centripetal direction. In one situation, tension can act in the centripetal direction and tension can behave like a centripetal force. In some other situation, n minus mg cos theta, the combination of mg cos theta and n acting in opposite directions, can result in the net centripetal force. It depends on that particular problem, on that particular case. So centripetal force is not a special type of force. One or the other force will act in the centripetal direction to give necessary centripetal acceleration so that the particle executes circular path. So that is centripetal force. If it is uniform circular motion, alpha is 0, there is no tangential acceleration, there is only centripetal acceleration. Whether it is uniform or non-uniform, what is common is centripetal acceleration. Without centripetal acceleration, there is no circular motion at all. And that centripetal acceleration is omega square r or v square by r. And at every point, the velocity is perpendicular to centripetal acceleration because centripetal acceleration is along the radius, velocity is along the tangent. Suppose at this point, if this is velocity v, and centripetal acceleration is perpendicular to it. So the centripetal acceleration cannot change the magnitude of velocity, but it changes the direction of velocity. And the tangential acceleration can be along velocity or opposite to velocity. If it is along velocity, it increases the magnitude. If it is opposite to the velocity, it decreases the magnitude of velocity. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.